So the last topic we want to look at is test-driven development. And before we do that, we briefly look at refactoring. So you all know refactoring. You improve your code without adding new functionality. You refactor your code to a better code, better quality, better design. And the whole idea of refactoring came from Kent Beck. He came up with that idea. There was a big project, and that project that didn't go very well. And they asked him, Kent Beck was a software consultant at that time, and they asked him, "Can you help us?" And he came on the project, and he looked at the code and the people and what they all did, and then he found there's a big inheritance hierarchy with 10, even more classes deep inheritance hierarchy. And then he asked the developers, what about this hierarchy? And then the developers said, yeah, that hierarchy is so complex, and we need to change something there. It takes a lot of time for us. So then he came up with the idea, okay, let's improve the quality of the code. So they went at that time the project manager, and the project manager said, okay, what does it cost? Well, a week. And how much functionality do we build in that week? None. We're only going to improve the code. And then the project manager said, okay, then we're not going to do it. If it takes a week and we don't gain anything, then we don't do it. And then what happened is a few months later, they killed the whole project. It got cancelled, completely cancelled project. And then Kent Beck came with that idea, refactoring. Refactoring is part of software development to improve your code. So Kent's mother, Grandma Beck, always said, if it stinks, change it. Meaning diapers. It's similar with code. If you have code smells, change it so you have clean, good code. So it's important, we talked already about quality of code and why it is important. And you grow software. You don't build software. You start small and it grows and it grows and it grows and it grows. That's why you need to refactor so the quality improves. If you just add code and it's crap software, then at the end you come at a result that everything breaks down. It's so hard to maintain this software. If you change something here, you break it here and here. You don't want that. So quality is important. But how do you do refactoring? You can only do that if you have these tests, these unit tests. That's your safety net. So I explained it already a few times. You change a few lines of code, you test. Change a few lines of code, test. Change a few lines of code, test. Oh, bug. Where is it? Okay, can only be the last few lines of code. Fix it, and then you continue. And in that way, at the end of the day, you've changed a lot. In a lot of very small steps, changed a lot, and you still have confidence that your code is still working correctly because you have the tests. And again, similar with testing, refactoring helps you write better code in a faster way. That's the key here, faster. If you don't do unit testing, if you don't do refactoring, you're a very slow programmer. And again, these are not the toys applications that you build here in class. These are the big, large applications where one or two or maybe more Scrum teams work for a whole year on software. So test-driven development. I explained it already. What you do, so the old way, you design something, you implement it, and you test it. You do testing after implementation. But that means you don't have a safety net. So you as a developer in this part and maybe also this up here. You don't have the safety net, so it's hard to change a lot of code. So what's the idea of test-driven development? You design something, and the first thing you do is you write a test. But the test is red here, it fails, because, well, actually, I didn't put in here the first time it will not even compile, because you don't have the code yet. You don't have the classes and the methods that you call in your test. But let's say you got it to compile, you test it and it's red because you didn't implement the details. Then you implement the details, then you test and it's green. All your tests work now. And then you look at the quality. If the quality is good enough, you design something else. If it's not enough, you refactor till the quality is high enough. You test again, and until it's green, then you continue. Main thing, you test, write the test first. So we call it red-green refactor. That's every time what you do. So we talked already about test-driven development. When we talked about API design, you should always start with the client first. That's what you do in test-driven development. Write the client first. How? So it has not so much to do with testing, but more with design. Design of your interface, of your methods, of the naming that you use and how much methods. That's the most important thing. So let's look at an example. So I go very quickly over this, but it's about the idea of test-driven development. So this is a list of user stories for a stack. So it's just one stack, so it's not an application, but these are the requirements for a stack. So here we create a stack and verify that is empty is true. Okay, we push a single object on a stack, and then is empty should be false. Push a single object, pop it off, and is empty should be true. Push a single object, remember what it is, pop it off, and verify that the two objects should be equal. Well, and then we continue. Push 3 objects, remember what they are, pop each one, and verify that they are removed in the correct order. Pop a stack that has no elements. So we continue. That are the requirements for a stack. So let's start with the first one here. So create a stack and verify that is empty is true. So what we do, in this case, and this is only the first case, I start with a test, but I also implement a stack. So I have a method stack test. I write a test here, test empty. I create a stack and I say assert true, so I didn't put the assert that in there. Assert true, stack.is empty. Then I want to compile it, so I write a stack here. It has a boolean empty is true. It has a method is empty, and I just say return empty. Now the thing is, you're not going to write the implementation of the stack here. You write only that code that you need to fulfill that test. And this is all I need. So I know there will be a push method later, I need a list later, but I do that later. And if I do it that way, that guarantees that I write the simplest, least amount of code lines that fulfills the requirements of the stack. And then again, this is just a stack. You might think, yeah, everybody knows a stack. I can write it immediately, but I had to give an example that everybody knows, that is small enough and that fits on a slide, but typically it's bigger. So maybe a whole shopping cart or an order. So now I have my test, I have my implementation, and I run it, and it's green. So in the first step, I didn't do the red one. You could do that. Let's go to the next one. Push a single object on the stack and verify that this empty is false. So I create a new test method, test push1, create a stack, push first element, and stack.isEmpty should be false. I run my test. So to make it compile, the stack needs a push method. So I add a push method. The only reason I do that is because so that the test compiles. Then I run it and I see it's red. Then I'm going to implement the push method so that the test passes. So the only thing I have to do is empty is false. And I test and it's green. For this test, the only thing I had to do, empty is false. Then I didn't show it, but in my test, this test here creates a stack. And in the previous test also creates a stack. So I refactor now my test code. So I add in before, create a stack, and then the two other methods are simpler. But it's also important, because test code is also code. You want to keep it clean and best practice and all these things we see. Then the third one, push a single object, pop the object, verify that isEmpty is true. So I push an object, I pop it off, and then isEmpty should be true. I add a pop object to the stack so that it compiles, I run, and it's red. Then I implement the pop, empty is true, and it runs. Then we go to the next one. Push a single object, remember what it is, pop it off, verify that the two objects are equal. So I have here, I use just an integer here, expected. I push that expected integer. I do stack.pop, and that's the actual, and I check that actual and expected should be the same. Then that means that pop should return something, an object. So to compile, I say here, return an object, and then here I have to choose something. Just say return null, NULL, so that it at least compiles and it's red. And then what I do is, now because I use push and pop, what I have to do is that when you push an object, I have to remember that object. So I have an element here that is filled when you push something, and you call pop, then that element will be returned, and the current element will be null again. So I return that element. So I return the same element that I pushed. I test it and everything is green. So there's still no list in there, even though I know eventually there will be a list, but for the first 4 tests I don't need a list, so I'm not going to write it. Then I refactor the stack so that the code is easier to read here. And then I go to the next one, push 3 objects, remember what it is, pop each one off. So now I need a list. So here's my test. I push element 1, 2, and 3, and then I pop the first one off, and that should be 3. Pop the next one, that should be 2. Pop the next one off, and it should be element 1. I run the test, it's red, and now I introduce a list here. So when I push, I add it, in this case in the beginning of the list here, the first element in the list. IsEmpty is basically only if the size is equal to 0, and pop, what you do is you get the top of the list, then you remove it, and that's what you return. And then I run it again. And then we go to the next one, pop of a stack that has no elements. So I say stack.pop pop. And actually, I expect that it shouldn't give an illegal state exception class. This is a way in unit testing how you can test an exception. This one passes, this one is correct if this method returns this exception. If you don't get this exception, the test fails. So I run it and indeed it fails. So in my pop method, I check if you call pop, if it is empty, I throw this exception. Otherwise, I get the top element, I remove it and I return the top element. And then everything is clean again. Then, while we're doing this, we discover new tests we didn't even think about from the beginning. So what about if I push null on a stack? Then verify is empty should return false because I didn't push anything. Push null on the stack, pop it off and verify that the value to returned is null. Push null on the stack, call top and verify that the value returned is null. Let's say these are my requirements. So I have to write that. So first I write the test here, push top, and then so first I push something here. So what do we want to do? We push single object, then call top, verify that is empty, returns false. So we push something, we call top, and then is empty should return false. So that means I didn't add a top method yet. So I add a top method and I just return null here, and that's correct because I only checked the is empty. And then again we find new tests. Push multiple items on a stack and verify that calling top returns the correct object. Push an item on a stack, call top repeatedly, and verify that the object returned each time is equal to the object that was pushed. So we make that, we make it work, we do this one, etc. And then you continue. Then call top on a stack that has no elements. So I should get an illegal exception state. So I have to implement that too. Then I refactor my stack and then I have these last three tests. So here at the end, this is my end result. So the first thing you see, I have a lot more tests than I have methods in my stack. There's also a lot more test code than I have at stack code. That's good. Also in the test I test the border cases, things where it goes wrong. That's also good. And I have the minimal code refactored, clean, for the stack. So if you would have asked me, write a stack, maybe you say now, well, this takes, I don't know, 20 minutes or half an hour. While if you ask me for a stack, in 5 minutes I have a stack for you. Could be. And then again, a stack is something simple. But what will happen if you just write it directly? You start writing some logic and, oh, no, I made a mistake. Okay, let's put this in a method. Okay, I need another method. Okay, let's do this and let's do that. And at the end, I have a lot of code. And then maybe I run it a few times. Yeah, it works. That's it. But that code typically is not clean. That code is hard to understand often. Maybe you have more code than you ever need. Maybe there's some methods in there that are not called anymore. At a certain point you needed it, and then you change something, but you were busy and there are a lot of methods, and the method stays there. Nobody calls it anymore. That's why this is so useful. So, coming back on quality. We've seen clean code is important. We've seen interface design. is important, and everybody who programs does interface design. We've seen unit testing is important. Now we come to test-driven development. So I can add two more things to the three things we have. That's test-driven development and reviews of the code. Both of them, what are the advantages of both of them? They improve your code even more. But there is a cost to it. Test-driven development, there is a cost to it. It goes a little bit slower than what you maybe normally do. That's just a little bit. Reviews does take a lot of effort, because all the code that is written has to be reviewed. But all these 5 of them, they are all best practices to get the best quality code you can have. And a lot of projects do this. They do test-driven development. They do reviews. They do all these techniques that we've seen. But also a lot of projects don't do it. Well, what I said, testing you should do. But sometimes I see a project that still doesn't do that either. But that's what they want. But it is worth the effort. It does save you time if you do all these best practices at the end. Because it is not a short-term gain, it's a long-term gain. So only companies or maybe the people who make decisions, when they realize how important quality of software is, then these projects do this. And there are still projects that don't realize that yet. So here we have more test code than actual code. Most time when in writing tests, our focus was in how the stack is used instead of how we implement the stack. And the stack implementation is clear and concise. That's the end result, and that's what you want. So here, best practices. The name of the test should describe the feature or specification, similar as in production code. The name of the method should describe what it does, similar for a test. A test should test a single concept. So all these best practices for unit testing, they're applicable here too. They are applicable for all testing. Strive for one assertion per test. Otherwise your test does too much. Start with the requirements with test-driven development. Also, trivial tests are important. They are your safety net. Treat your test as production code. Maintain, refactor, keep clean. Just making it work isn't good enough. No. You focus on all the ways this method is called, all the border cases, etc. And tests should never depend on each other. We've seen that too. Challenges? Discipline. What I see, those programmers who do this daily, they don't want to do anything else. It's sort of a rhythm. Once you get too used to it and you see the advantages, you keep doing it. But there is a hurdle you have to go over. And that hurdle is for a lot of programs pretty big. So in general, the interesting thing of test-driven development is that whoever you ask in the field of software, everybody agrees test-driven development is good to do. You get just better code. But then if you ask who really applies this, then I guess you get to 20% of all the projects do this. The majority doesn't do it. But again, these 20% that do it, they don't want to do anything else. Here, developers are stubborn and lazy. They always think, we should write software fast. We don't have time for it. All these kind of things. that's short-term gain, not long-term. It's hard for developers to drop bad habits, and management doesn't understand what internal quality means. So a manager will typically not tell you you have to do test-driven development, or you must have a manager that really understands software development and quality of the software. But it's something you should do, similar as refactoring, clean code, interface design, something you should do. It's not something that somebody has to tell you to do. So that brings us to the main point. Testing is an important aspect of software development that increases the quality of the code. Actually, you develop faster if you test. The daily connection with our divine source increases all important aspects of life. So you can compare that. If you don't make that connection, then you don't get that enrichment. Similar, if you have high quality code, you have all the advantages of that high quality code. Easy to maintain, easy to change. Similar, if you don't, like the main point from yesterday, if you don't go to the bank, what do you want to do on a marketplace if you don't have money from the bank? Similar, if you don't have that daily connection with our divine source, that unified field, that pure consciousness, then you don't have all the enrichments, all the happiness, all the clarity, and all the other advantages as better health and all that. You don't have these advantages, and you want these advantages.